Hello class, this is CSE-4410, sections 1 and 2, chapter 6. So for this chapter, we are looking at making a 2D platformer. So if you wanted to make this for your group's project, then here are the instructions for that. So, I have already started with creating a new project, and much like with the memory game, we want to go to new project and select 2D core, give it a good name, and click create project. So right now Unity is busy with setting up the project. So with that, I am going to the corresponding GitHub repo. Oh, it's already done. Anyway, much like the memory game, we have a few assets that we have to download, and it's going to be from the same GitHub repo that has all the completed projects by the author. So, what we need are two files, blank.png, which is just a little white square, and stickman.png, which it's a little bit hard to see because the color contrast is, well, nearly gone. There's no color contrast here, but it is 6 images of a stickman in different frames of a walking and idle animation. So, it also means that this project is going to have us do some animation. So, this is animation as it pertains to 2D animation, where we have frame by frame animation. But I've also linked on Canvas a corresponding YouTube video where you can create animations using only one sprite in like 3 minutes. So the link to that is on Canvas. I might link it on YouTube as well in the description. Okay, so we download those two sprites. We'll go to Unity because it's already finished creating the project. I'm going to create a new folder. Call it sprites. Move my face cams so it's on the side. And now I have already downloaded these sprites ahead of time, so here we are. So I'm just gonna drag and drop these two images, blank.png and stickman.png, into here in the project view. Drag and drop those into the sprites folder, because it's a very good idea to get organized with our projects. Okay, so now we have our stickman and our blank. So, what I'm gonna first do is, remember, when you're working in a 2D game, any images that you drag and drop, they are going to become, they're gonna turn into, when you drag and drop them into the scene, they basically become game objects with a sprite renderer on it. So now we can just take, what I did was drag and drop the blank, and now I want to turn that into a platform. So what I can just do, if you look really closely, you'll see a little icon that looks like a chain link with a slash going through it. Unclick that, so it looks like a chain link now. It looks like a chain. So now I'm going to change the Y scale to something like 50. Actually, no. We need to disable constraint proportions. My mistake. So if we do that, then we can scale the X, Y, and Z scaling values independently of one another. So I can now do this. Take that and just squish it down. And we'll move this over here. So now we have a platform. I'm gonna duplicate this again. So that was Control D to duplicate. Yeah, Control D to duplicate. Drag this, make it 5 and 5 and 1. So these are 2D objects, and they still have X, Y, and Z values. That's because Unity was already set up for 3D games. It's set early on. Unity was only for 3D games, and then 2D stuff was added onto it. So even though this is a 2D game, there are still some 3D things attached to our. There's still some 3D stuff on our game objects. So that's why we have a Z scale, even though we don't really need it. There is also a Z position, even though we don't really need it, though we can use it for some cases. So really the only thing that we need to do relating to the Z axis is having to do with rotation. So we still need a Z axis because rotations are about axes. They go around axes. So X rotation doesn't really work in this context. Looks like squishing. Y rotation also doesn't work in this context. It also looks like squishing. So really it just makes more sense if we still have all of this 3D stuff even though we're in a 2D context. Anyway, I now have a cube. Well, it's really a square. I have a square and a platform that I can use for our platformer game. I need a few things attached to this. So I'm going to select both of these. Oh, before I do that, I'm just going to rename these. So this is going to be the platformer. This is going to be the platform. And this is going to be a block that's going to block our player. So now we can just drag and drop the player into here, right? Not so fast. In fact, before we even get to that, I would like to add a few components to our platform and our block. And that is not a platform effector 2D. We'll get to that in a bit. We need a box collider. 2D. Attach those. So now we have, it's a little bit hard to see, but there are green outlines on our boxes now. Excuse me. So these box colliders are going to be for our player, so that when the player walks on these things, they won't just fall through the ground. I'll show you what happens if we forget box colliders. So let's work on the player. As I said, if we just drag and drop this into our scene right now, that's multiple stick people. We don't want that. So in the inspector, let's look at our stickman sprite sheet. Because this is a sprite sheet, it's going to be multiple sprites. So we have not one sprite, but multiple sprites. So set sprite mode from single to multiple. Click apply. Then click on sprite editor. So now we have this interface. We have this window where we have a slice. We have a sprite editor where we can slice our sprite. So there is an automatic way to do this in Unity. It looks like this. Now this can work, but the problem is the centers for each sprite is going to be different, and it's just going to be a lot more. It's going to be a lot more consistent if we control how we slice this. So let's not do automatic slicing. So click revert. I'm going to have a slice by cell size. The default is 64 by 64. Let's do 32 by 64. So now each. Okay, 32 by 64. So that cuts up our sprite sheet into 8 frames worth of animation. But really 2 of them are blank. If those are blank, then Unity will just not turn those into sprites. So we have 6 sprites. So 32 by 64 sprites, click slice, 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 slice. Click apply. And when you look at this sprite now, see this little button that looks like a play button? Click that, then we can see all 6 of our sprite. We can see all 6 individual sprites from our sprite sheet. So all I gotta do is just drag and drop one of these. So that's gonna be our player. So I'm gonna say this is our player. But we're not at the point where the player can just move around. We don't have any controls. But what we can do is this. Let's get the player ready for movement. So I'm going to add 2 more components to this. The first one's a box collider. The second one is a rigid body. So I have a box collider and a rigid body. To be a bit more specific, these are box collider 2D and rigid body 2D, because there are 2D and 3D counterparts to these components. We're working with a 2D game, therefore we need a 2D. We need the 2D counterparts. So on the rigid body, I need to do a few more things. Under constraints, here, click on freeze rotation so the sprite will not rotate. So, basically there are certain forces that can be applied on a rigid body that will make it spin. We don't want that to happen. So now, if I click play, our player falls to the ground, and there you go. The player is safely on the ground, not flying to the floor. In fact, I'm going to turn off the box collider here to show what would happen if we forgot to add a box collider on the floor. So what happens is pretty simple. The player just falls through the floor. Game over. The player fell out of the world. Well, that's not what we want to have happen, so leave that box collider on. Okay, there are a few more settings we need to do on the player, and that is, let's turn off gravity by temporarily setting gravity scale on the player to 0. So on the rigid body component for the player, set gravity scale to 0. We also need to do this. Set collision detection to continuous. Okay, so hold on. To reiterate, we need box colliders on the block and the floor so that the player can, well, basically step on things. We need a rigid body on our player so we can apply forces to our player to move the player. And we also need a box collider on the player so the player can collide with things. So, with gravity scale on our player set to 0, if I play the game and I set the player a little bit off the ground, if I play it now, well, the player's not falling down. I am pressing the arrow keys on my keyboard and nothing's happening, and that's because we did not write any keyboard controls yet. Let's do that now. So I am going to go back to the assets folder here, and I'm going to create a new folder that's going to contain all of our scripts. I'm going to start with the platformer player script. So create new C# script, platformer player, that's what it's going to be called. I'll add this to the player by dragging and dropping it from the project view to the hierarchy. So now we have, well, not only the box collider and rigid body, but also the script. So let's open that script right now in Visual Studio. And I'm going to add the following code. Give it a minute. So let's just get this set over here. Okay, first is going to be a public float speed. So a public field, that's going to be our speed. Let's set it to 4.5. I also need a private field for the rigid body. So I'm going to write this private rigid body 2D body, and in the start method I'm going to say body equals get component, and in angle brackets rigid body 2D, and then left and right parenthesis and semicolon to end that line. Okay, the only reason why this isn't working is because I spelled it wrong. It's lowercase b body, not rigid body, capital R and capital B. There we go. Alright, now in the update method, I'm going to add the following code. Float delta x equals input.getAxis, and then in a string, the word horizontal. So it's much like the getAxis from the first-person shooter from earlier. I'm going to say that times speed. So it's going to listen for input from the buttons that correspond to horizontal movement. That's going to be multiplied by our speed. And then I'm going to create a new vector 2. Vector 2 movement. And this is going to be a vector that represents moving either to the left or to the right. That's going to be vector 2 movement equals new vector 2, and then we're going to pass in delta x as our x component and body.velocity.y as our y component. And then on the line after that, I'm going to say body.velocity equals movement. And there we go. Save all that. Now if I click play on our game here, what should happen is this. We should be able to move the player left and right. And indeed we can. Well, it's just the sprite that's just sliding left and right. But I'm going to deviate from the textbook for a little bit of this video and do a few things here. First, let's turn gravity back on for the player. So I'm going to say gravity scale equals 1. Because really, a lot of what I'm talking about does not necessarily require animations. It's just that it looks good with animations. So I'm going to talk about a lot. So I'm going to talk about a lot of what goes into player controls here. We don't have jumping quite yet. But I will talk about, for example, what if you wanted to get this cube to move? Well, it turns out we don't need any special code to make that cube move. All I really need is a rigid body. So now, all I gotta do, if I have this cube in my way, I can just push it out of the way. And if I fall off the cliff, well, there goes our player. There goes my hero. Okay. There are, however, a few bugs in here that we'll address right now. And one of them is this. It's best shown if I make gravity really weak. So 0.1 gravity scale. And now if I move the player to the side really carefully, and I am holding down on the right arrow button, and my player is clinging to the wall for his life. If I let go, then the player starts falling. There is a component where if we attach it to the floor, it will prevent that from happening. So yeah, I am going a little bit out of order from the textbook, but it's simply because a lot of what I'm talking about is a little bit more important than the animations. If anything, I'm kind of saving the animations for last. Okay, so that component is a... What we need is a platform effector 2D. We need to change a few settings on this as well. So, platform effector 2D, attach that to the floor. Well, platform. Yeah, we'll attach that to our platform. We're going to change a few settings in here. One of them is one way, use one way. Let's turn that off. And then in here, in the box collider, click use by effector. So now if I play this game and try to move to this off the... Okay, let me try that again. What I was trying to do is get my player to the edge of the thing. Set gravity scale back to 0.1 for demonstration purpose. And now I slid off the edge of the platform. So yeah. Okay, that gets rid of the bug of where the player can just cling to the edges of the sides of a platform. Alright. Let's get so that's all of our basics for getting just the simplest platforms done. Maybe it's a good time to work on the animations. So I did work a little bit out of order compared to the book, but I think now is a good time to work on animations. Again, and by the way, there is a video on YouTube that has an even quicker head start on animating. And the video is only like 3 minutes long, so. And what's great about that video is you don't even need an entire sprite sheet's worth of animations. You can just get away with one sprite, and that's really all you need to start animating. But for our case, since we have a set of frames already, let's look into setting up animations for that. So, what I've done so far was I set up a few game objects for our player, our block, and a platform on which you can walk. I added a few settings to get the player to walk on the floor. I added a few things to make the player not stick to the edges of platforms. I've also made the block here able to move to the side by being pushed by the player. Let's work on animations. So, I'm going to go to our sprite sheet, and I'm gonna select these first 2 frames. If I try to drag and drop these two, I'll be greeted. If I drag and drop these 2 frames into the same view, I'll be greeted with this create new animation window. I'm gonna call this Stickman Idle. Press enter. So what happened now? Well, several things. First, we have an extra stickman here. We don't really need an extra stick figure, so I'm just gonna delete that. We also got 2 things, because the heart of animations in Unity is based on 2 things. The first one is animation clips. So that's what this little thing here with the triangle icon is. That is an animation. The other one is an animator controller. So they have similar sounding names, animation and animator, but their full names are animation clip, which is this one, and animator controller, which is this one. It's the one whose icon is a bunch of squares. Well, it looks like squares, doesn't it? Well, really what it's supposed to symbolize is a flowchart, or I should say state diagram, because an animator controller it's exactly that. It's a state machine where you have a bunch of states, and each state each state is an animation clip. What the controller has is a bunch of parameters, and if those parameters meet specific conditions, then the state machine, that is our animator controller, will switch from one animation clip to another. So that's what an animator controller is. It's basically a state machine where we can program under what conditions we are allowed to change from one animation clip to another. Okay, so let's work on adding the next animation clip. So I'm going to select the next 4 frames in our sprite sheet, drag and drop into the scene view, create new animation again. This one is called Stickman Walk. Okay, so now we have another Stickman figure here. delete that because we don't really need it. Now we have two animation clips. The first one is the walk. No, the first one is the walk animation. The second one is, yeah, I mixed it up. The first one was the idle animation, and the second one is the walk animation. That also it also gave us an extra animator controller. We don't really need that, so I'm just gonna delete that. Delete selected asset. You cannot undo this if you delete it, but I want to delete it since we already have one of these. I'm gonna rename this to Stickman. Just Stickman. So now we have our Stickman controller, our animator controller. How do we view this thing? So I can just click open here. And that takes us to this interface where we have our state machine. So currently we only have one animation here. So I guess this differs from if you're gonna end up learning about the theory of state machines, it's this. In the theory of state machines, you have what is called an entry state, which is indicated by a state with an arrow coming into it from nothing, and an exit state, no, an accept state. So this differs from the usual theory of state machines in that, like, for example, formal languages and automata theory, press Alt-N to use GeForce Experience in Game Overlay. Anyway, in the theory of, say, formal languages and automata theory, we would draw states like this. So this is a start state indicated by the arrow. We would have arrows that go from state to state. There might be states with arrows that loop back on themselves. There could be states that go back to other states. And if we have an accept state, then it's indicated using a double circle that looks like that. So that's how state machines are drawn in, say, formal languages and automata theory. It's not quite the same in Unity, but a lot of the basics are there. We have arrows going from state to state, indicating that we have transitions that go from one state to another. We have three mandatory states here: the entry state, the exit state, and the any state. Really, all we really need to deal with here is the entry state. So, and even then, that connection is already set up for us. So, really, we don't need to deal with these three states at all. We'll just put them aside. What I need to do now is I need to add in my walk animation. So here we are. Just drag and drop it from the project view into the animator view. So if I right click on one of these states, it says one of our options is make transition. So I'm going to create an arrow that goes from the idle state to the walk state. But I'm going to do it again because I need to make another transition from the walk state back to the idle state. Alright, so that's not quite done yet. In the parameters tab here, I'm going to add one parameter, and it's going to be of a type float. I'm going to call it speed. Press enter. So now we have a speed parameter, and this is the parameter that the controller is going to use to determine whether to move from the idle state to the walk state or back. And it's this simple rule. If we are walking fast enough, then we move from the idle state to the walk state. If we are moving slow enough, then we're going to move back from the walk state back to the idle state. So here's how we're going to do that. First, I'm going to select one of the arrows, and that is the arrow that goes from the idle state to the walk state. In the inspector, there is a list of conditions, but it's empty. Add to the list by clicking the plus. We have a speed greater than, I'm going to say greater than 0.1. So if our speed is greater than 0.1, then we're going to move from the idle state to the walk state. We're also going to uncheck this checkbox here that says has exit time. So uncheck that. So now we're able to go from the idle state to the walk state. But the problem is now we're stuck there. So we need to have this transition set up so that we can move from the walk state back to the idle state if we are moving slow enough. So I'm going to uncheck has exit time. I'm going to click the plus here so we can add a condition, and that is speed less than 0.1. And just like that, our state machine is all set up. But if we are to play this game right now, nothing's going to happen because we still need to program using this controller in code so that way we can move from state to state. Also, there is actually another thing we need to do too. So if I go to the scene view and select our player, we have to add one more component. And that is an animator component. So here is an empty field. Here's a blank field in which we can attach our animator controller. So here's our stickman controller. I'm gonna drag and drop that all the way here. So now if I click play, now our player is moving his arms. And that's because it's looping the idle animation. Basically, indefinitely. It's looping that animation indefinitely. So now we know that our animation is working. It's a little too fast though, so it's also gonna be worth changing the speed of our animations as needed. So I'm just gonna I'm gonna go back to our animator controller, click on the idle state, and I'm gonna set its speed down to 0.2. Press enter, and if we play this game again, might be a little bit hard to see due to the scale, but our player's just standing there, just standing there. But our animation is playing a lot more slowly, which is, well, more fitting for this game here. So it's not too fast, basically. Alright. However, I am pressing the arrow keys and he's not walking. That's because we need to basically say in code to the controller the player is walking. So let's go back to Visual Studio and add all that necessary code. I'm gonna need to add another private field here. So private animator anim. I'm gonna say anim. In the start method, I'm gonna add the line of code anim equals get component animator. Now, in the update method, I'm gonna add a few more lines of code. The first one is this: anim.setFloat, and this method is part of the animator, and it requires two things to be passed in: the name of the parameter for which we are setting, and that is the speed parameter. So speed. And then we're gonna pass in the absolute value of our delta x value here, because that is horizontal speed. Now, one thing you may have learned in, say, physics is the difference between velocity and speed. And speed is basically how fast you are going. Velocity is how fast you're going and which way you're going. We care more about the how fast you're going part. So that's why when I say anim.setFloat, not only do I say speed, but I don't care about which way we're going. All I care about is how fast are we going. So I'm going to say mathf.abs, and this is going to return, this is the absolute value function here, math.abs delta x. So now the controller, the animator controller, is now being told how fast the player is walking. And if you remember from our, if you remember from the animator here, we move from state to state based on how fast, based on how high our speed is. So if it's above or below a certain threshold, it's going to switch from one state to another. So that's all that's needed to get our animator to work. However, there is one more addition after that. There's one more line of code, maybe a few more lines of code to add after that. And it is this: if exclamation point mathf.approximately, and I'm going to pass in delta x and 0, transform dot local scale equals new vector 3. For the x component, I'm going to say mathf.sign delta x. For the y component, I'm going to say 1, and the z component, I'm also going to say 1. So, what does all of this do? Well, remember, this line of code basically tells the animator controller how fast are we going. What these lines of code do is it's gonna flip our player either left or right depending on which way we're going. So let me show you what that looks like. If I click play, because all of this is set up, we should now see the player walking. And we do. So that one line of code here, as I said, that is to tell the animator controller how fast we're walking. What these two lines of code do is simply flip, well, I should say mirror the player depending on which way we're going. That way we don't need separate sprite sheets for going left or going right. So we can use, because in the sprite sheet we only have one set of frames for walking to the right. So it means we don't need an extra set of frames for going to the left. All we gotta do is mirror our character, and there we go. We have a left walking to the left animation for free. Is this always a good approach? It depends on whether you have, say, what if you have, I guess I'll say it like this. Sometimes you might have, sometimes you have characters who have some asymmetric feature. Like, I don't know. Look at this guy here. So, this is Motoro of Bionicle. And his prominent feature is this thing on his right eye that's basically, I don't know what you would call this, scope or whatever. Well, anyway, this is a prominent asymmetric feature. So what if you featured this character in a, what if you had a character like this in your game? Would you need a second set of sprites would you need separate left walking animations and right walking animations? Possibly. Okay, so now we have our animations all set up. We have all our animations set up. What we don't have yet is jumping. So let's work on that next. So for this to work, we need to have on the player, if in the rigid body we have left gravity skill at 0, let's set that back to 1. Okay, so gravity in a game in Unity is itself a setting. So go to Edit and go to Project Settings. We have this window here that has all the settings for our game. Under Physics 2D, we can set that to say -40. So if we need stronger gravity for our game, well, that's where we go to set it. So let's add the ability to jump right now, and for that I'm going to have to edit the platformer player script again. So I'm going to start with another public field, public float jump force equals 12, and again this is a value we can change in the inspector. Down here I'm going to add another if statement, and that is if input.get key down, and in parentheses key key code dot space body dot, and this is the body, rigid body that we had attached to the player. So body dot add force vector2 dot up times jump force. That's the first thing we pass in. The second thing we pass in is force mode 2D dot impulse. Excuse me. So what does this do? So this simply just listens for whether the spacebar key was pressed down, not held down, because that is something else entirely. There's get key down, and get key up. What we really need for this is get key down. So that is the transition from the button not being pressed to the button being pressed. When we do that, we're gonna apply a force to our player that makes our player jump up, but it's applied as an impulse. So it's not gonna be the player gradually rising up above the ground, but rather all our forces applied all at once, so our player just jumps up. Okay, so let's try that out. Click play. Press space, and our player can jump. Press space, and our player can jump. I'm like 1,200 meters in the air and still climbing. Now I'm 2,000 meters in the air. So, yeah, our game has double jumping. So, while our player is falling back down from the stratosphere, oh, by the way, outer space is defined as 100 kilometers up from the ground. Oh, there's our player. So yeah, we weren't in outer space just yet. So how do we make sure our player cannot double jump? Oh, by the way, do you even want double jumping in your game? I guess it depends on whether you want that to be a feature or a power-up. But for our purposes, we're gonna say that is a bug, so we're gonna patch it out. And it's pretty simple. All we gotta do is add an extra condition in here, we add an extra condition that says, if the player presses down space and the player is on the ground. The player is on the ground. Well, we probably shouldn't write it that way, but I will say this. I'm going to create a variable called grounded, and then I'm going to say something like this. Actually, no. I'm going to say bool grounded equals true. So yeah, we need a Boolean value that is set to either true or false, depending on whether the player is on the ground or not. How do you tell that the player is on the ground? Well, it's a bit more code, but it basically boils down to this. We're gonna create a little collider. We're gonna create another collider below our player, and if that overlaps with anything, then we can say that the player is on the ground. So how do we do that? Well, first we need to get the bounds of our player's box collider, and then use that information to create two new corners that are going to define the bounds of another collider that's going to be the little bit of collider, the little bit of box collider that's going to be below our player that detects whether we are on the ground. So here's what that looks like. Vector3 max equals input.getAccess. No, not input.getAccess. It's just going to be box, and that is our box collider, by the way. Box.bounds.box. Oh, yeah, I forgot. We actually need to get a reference to our box collider. So, I'm going to say, yeah, before we even write any of that, I should add this. So, private box collider to D box. And in the start method, box equals box collider to D. Actually, no. That should be part of a get component method. So, box equals get component box collider to D. There we go. Now we have a reference to our box collider, so now this part should work without throwing any errors. So vector3 max equals box.bounds.max. Vector3 min equals box.bounds.min. Vector 2 corner 1 equals new vector 2 max.x comma min.y minus 0.1 f. And that's the first corner for our bounding box that is below our player. So now we need the second corner. Vector 2 corner 2 equals new vector 2 min.x min.y minus 0.2 f. I'm going to then say collider 2D hit equals physics 2D dot overlap area corner 1 corner 2. So basically what all this code does is it's gonna create a small bounding box below our player, and it's going to detect whether it is overlapping with any other box colliders. So if this, so if there is an overlap, then this is going to be not a null value. So what this is, we can determine whether our player is on the ground based on whether this hit is null or not null. So I'm gonna say bool grounded equals false, and then if hit does not equal null, then grounded equals true. So that's what the textbook says, but personally, I like my code to be, sometimes I like my code to be terse, maybe a little bit too terse at times. So what I would personally write, and this, what I'm going to write is equivalent to these 4 lines of code. So these 4 lines of code is going to be equivalent to the 1 line of code I'm going to write, and that is hit does not equal null. So this is going to evaluate to either true or false. Yeah, this will evaluate to either true or false, and that's the value that's going to be assigned to this grounded variable here. And then I'm going to use that in here to determine, am I allowed to jump or not? So let's try that out. So let's stop playing our game, let's start it up again. I am vigorously pressing the spacebar, and I can only jump when I am on the ground. So it works. Nice. And I can knock over that cube. And now I'm done. What else can we do? Well, there are a few more things there are a few more features that we can add to our game. One of them is this. Let's duplicate this platform and rotate it. So you see these little blue dots on the corners of this platform here? I like to call them sizing handles, but if you move the cursor really close, you'll see a rotation icon next to the cursor, and that means I can rotate our platform. So now we have a sloped platform. We can place it over here, say over here, and we can get our player to move up the platform. So I'm gonna press play now and see how well our player walks up the platform. Walk, 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 walk. So the textbook talks about how if you have a platform like this, your character might end up sliding downwards. That must be something that is specific to certain versions of Unity, or it might be dependent on how inclined the platform is, or there might be other settings that I myself not even know about. But basically, just in case your player is sliding off a platform like this. Now, the reason why my player is sliding down is because I made the platform really steep. But let's just say that we want the player to be able to climb these kinds of slopes. Now, the code addition to that is pretty simple. It's basically, we're going to turn off gravity for the player if the player is on the ground. So I'm going to stop the game, and I'm going to find our script here. The code addition the code addition for that is pretty simple. So this is got to be right before our get key down. And that line of code is as follows. Body dot gravity scale equals. And on the right hand side, it's going to be a ternary operator. So it's going to look like this. Grounded and mathf dot approximately delta x 0. Oh, by the way, why mathf dot approximately and not something like this? Why not this? Well, the short answer is floating point precision errors. Sometimes you'll have a value that's like 1.1, but really behind the scenes it's like 1.000003 or something like that. And that is because floating point values are base 2 values. They are not base 10 values. So when we say 1.1 in decimal, then that is 1.1 and nothing else after the 1. And if there is anything else, it's going to be an infinite string of zeros. In floating point math, that 1.1 is going to be 1.00000 and then some other number. And that's because 1/10 in base 2, that is a repeating binary value. So you know how in base 10, if you divide by 3, for example, 1/3 is 0.33333333333, and it goes on forever? Well, base 2 has the same thing, but with values that are divisible by 5. And more generally, it's gonna be the same thing. Any value that is not divisible by 2 in floating point, it will be represented as an infinite decimal. I guess I shouldn't say decimal anymore. It's going to be represented as decimal point, or I should say binary point, and then some infinitely repeating sequence of binary digits. So that is the problem with floating point. And because of that, we can't really say delta x equals 0f. Rather, we need to do something else, and that is math f dot approximately delta x 0. So I'm going to say that, and that's going to be the left-hand side of a ternary operation. So that is going to be a question mark. Huh? So this is a ternary operator. Basically, is this condition true? Question mark. If so, assign it this value. If not, assign it some other value. So I'm going to say 0:1. So if you've never seen a ternary operator before, then basically the format is this. Condition. Is it true or is it false? If it's true, evaluate it to say that the value is going to be this. If it's false, say that the value is going to be this. So, if the player is on the ground and our speed is about 0, then we're going to turn off gravity for the player. Otherwise, gravity is going to be turned back on for the player. So that's what this says here. So, if this works. Basically, anytime I am on the ground, gravity is going to be turned off for the player, so we don't slide down this slope anymore. So that's all there is to it, to keeping the player from slipping down a slope. Excuse me. So that's neat. What else can we do? So that is a sloped platform that we could have in a platformer game. How about a one-way platform? So, remember what a while ago I added a platform effector 2D and then I changed a setting in here called, and that setting was use one way? Well, if you want to make a 2D, if you want in our 2D game a one-way platform, I'm gonna demonstrate this. So this is gonna be one-way platform, and I'm just gonna resize it. So I'm just gonna resize it for demonstration purposes. I'm gonna move it here. So to make a one-way platform, what we need is a platform effector 2D. So this was already attached to this game object, and what I did was, when I copy pasted when I copied this game object and made it into a one-way platform, it copied all the components that were attached to it as well. So all I gotta do is set this to be a one-way platform. So now I have a little blue dome here. That is an indicator that this is now a one-way platform. How do you know? Well, if I jump on to this cube and then jump through the platform, there we go. That's how we know we have a one-way platform. Also, one thing we can do is if we rotate this 90 degrees sideways and then move it here, what we can instead create is a one-way door. I can walk through that platform, but now I can't walk back the other way. One-way platform. Nice. How about a moving platform? Because in a lot of platformer games, you have platforms that move up and down, side to side. Maybe some combination of both, up and down and side to side. Or it might move in a zigzaggy path between other obstacles. Let's stick with the one-way platform that can move linearly from one location to another. So, how do we do that? Well, for a simple platform that moves linearly from one point to another, we need to do something called linear interpolation. So it basically says, if you have 2 points in space, draw a straight line between the two, and if you want to interpolate, that means find some position on the line that is some percent from one position to another. Some percent from one position to another. So that is basically what linear interpolation is. We draw a straight line between two lines, and then we add some point between the two that is some percentage from one point to another. So that's what we're doing. So for us to create a moving platform, we need 2 points. The first point is going to be a starting position, and the second point is going to be a target position. But really, once we have, what I'm trying to say is, we can narrow that down to one position because we already have one position for free, and that is wherever the platform is right now. So we can use that as our start position, and then all we gotta do is write a script where we can program or assign in the inspector a target location, and then have our platform move from its current position to that new position and back, and then it'll oscillate back and forth for however long the game is playing. So let's add that script right now. I'm gonna call it moving platform. So this is going to be a script that attaches to our one-way platform. So now our platform is both one-way and it's moving. So I'll just drag and drop that to here. So one-way platform is now also a moving platform. Here's the code that we add. Sorry. So now we're gonna go edit this script here, moving platform. Double click so I can open that in Visual Studio. I'm gonna add a couple of fields to this. So, public vector 3, finish position, and we're just gonna default that to be vector3.zero. Vector3 0. Vector3.0 basically. We also need another public field for how fast do we want this platform to move. I'm gonna say public float speed equals 0.5f. Now I need a few private fields. The first one is going to be our start position, but we can get that based on where our platform is. So I'm going to say private vector3 start position. And if you wanted to, we can have two public fields instead. So it doesn't matter where we place our platform, it's just gonna ping pong between our start position that we can set in the inspector and finish position that we can set in the inspector. For now, I'm just gonna go with the start with wherever the game object is and go to some other position and back and forth. So there's nothing after the equal sign. In fact, there is no equal sign. It's just private vector3 start position. I'm gonna add another private field, private float track %, and then I want to set that to 0. And finally, private int direction equals 1. Okay. Next thing we need to add is one line of code in our start method, and that is start position equals transform dot position. So now we have our start position, which is wherever we have our game object. So now in the update method, I'm gonna add a couple of lines of code that's gonna do our interpolation. Okay, so first, track % is going to be this. Track % plus equals direction times speed times time dot delta time and then float x equals finish position dot x minus start position dot x times track % plus start position dot x. And then I'm going to duplicate this line, except I'm going to replace all the x's with y's. Why? Because we need an x value and a y value. That's why. Finish position dot y, start position dot y, start position dot y. So now I'm going to create a new vector3 and then assign that to our object's position. So that is going to be transform dot position equals new vector3 and then x y start position dot z. Now there are actually a few methods in Unity already that do linear interpolation for us. This is a rather long way to do it, but that's because we need to preserve our z values. But this is just one way to do it. All we gotta do now is, the only thing we have to add left is how to reverse from going forward to going backwards, and that is this code. If direction equals 1 and track % is greater than 0.9 f or I'll just copy paste that direction equals -1 and track position is less than 0.1 f. Then direction times equals -1. So that's how we reverse from moving from in one direction to moving in another direction. So give me a bit. and we'll try this out in a little bit. When I pause recordings like that, it's because I want to really double check that what I'm saying is correct and I didn't make any and I didn't screw up along the way. So anyway, let's play this now, and we're gonna see that platform move between one position and another. And what's it moving to and from? Well, our platform started here, and in our one-way platform object here, in the moving platform script, it was set to a finished position of the origin. But the thing is, we can change that to be whatever we want, so like we can just move it over here, and it is off the screen, so let's just change it maybe like this. However, the start position is not going to update because that was already set when we started the game. So maybe it might be worthwhile to modify the script so that we have a start position and finish position that are both programmable. So that's something we can do. Something that we could do. So now we have our moving platform. Let me just restart this game so we can better play with the moving platform. So what I'm going to do is I'm going to jump over here, and by the way, what I did to make this block move, that wasn't in the textbook at all. I just did that because, well, it required no code, and it might be a feature that we might want to have in a game. The ability to push stuff around, and possibly topple it over. However, if we don't want that to topple over, that is a simple setting that we can adjust. Because this cube here, this block here has a rigid body, we can also freeze its rotation. So no forces will ever make it rotate. So let's play with this platform. I'm going to jump up, and you can probably see the problem already, and that is the platform is moving, but I am not moving with the platform. And I should be moving with the platform. And now I fell down. But that is a simple fix. In fact, let me just demonstrate it while the game is playing right now. So I'm gonna move over here. Jump up here. Okay, let me try that again. What I really want to do is pause it part way. Pause. And with the game paused, I am going to turn the player into a child object of the one-way platform. So now, the player is moving with the platform. However, when I start moving on the platform, my player gets stretched out. So the problem is this. If our platform has a scale that isn't 1, 1, 1, our player object is going to inherit whatever scaling values the parent object has. So our one-way platform is now the parent object of our player. Our player now is now a child object of the one-way platform. The one-way platform has a scale value that isn't 1, 1, 1. In fact, it's 20.4, 1.9, and 50. And the player basically inherited all of those values, even though it doesn't say that in the inspector here. So remember when I said that if we do any sort of transforms on a game object, it will apply those to all objects that are children of that object? Well, because the one-way platform is itself scaled up, all child objects attached to the one-way platform are going to inherit the scaling values that the parent has. So that's why our player is, well, wide. Okay, so now we have to fix that bug now. Okay, so really what we need to do is two things. One, we have to encode make the player a child of the moving platform, but also fix this thing where the player gets stretched. So really we need to do two things. One is to make the player a child of the one-way platform if the player is on the one-way platform. That's number one. Number two, keep the player from becoming too wide by compensating for the scaling that the parent object, the one-way platform, has. So, let's do that in code. For that, I'm gonna need to open the platformer player script again. And remember when we had declared a value that we called hit? It's here. Between that and all the other code, I'm gonna add the following code. Moving platform equals null. If hit does not equal null, then platform equals hit dot get component moving platform. So what this says is, remember when we had all this code that basically detected for whether the player is on the ground? Well, that code is basically detecting whether the player is on the ground. But we can use that to our advantage to tell what are we standing on. So what this says is, if the player is on the ground, really, I can make this a lot more easy to read if I just copy this, because this is equivalent to this, and this is being assigned to this. So this can be placed in here. If the player is on the ground, we're going to see whether what we are standing on is a moving platform. So if it is a moving platform, if what we're standing on is a moving platform, then it means that get component method is gonna try to get the moving platform component on whatever game object we were standing on. And if there is a moving platform component attached to it, that means we are on a moving platform. That means if platform does not equal null, then transform.parent equals platform.transform. If we are on a moving platform, we are going to make ourselves a child object of the moving platform game object. Else, if we are not on a moving platform anymore, then we're going to set our parent to be nothing. Okay, I put that in the wrong place. Let's fix that up. So if we are on a moving platform, then we are going to make ourselves a parent object of the moving platform. Otherwise, we are going to make ourselves a parent of nothing. No, we're going to make ourselves a child of nothing, I should say. So, if platform does not equal null, transform.parent equals platform.transform. Else, transform.parent equals null. So that is the code that will make us stick onto the moving platform if we're on it. However, there is still that one issue of the player being stretched that we gotta fix as well. So, to fix that up, we're gonna have to counteract the moving platform's scaling values. So I'm gonna say this. Vector tree player scale equals vector vector3.one, vector3.1. If platform, if platform does not equal null, player scale equals platform dot transform dot local scale. And if exclamation point mathf dot approximately delta x comma 0, then transform dot local scale equals new vector3 for the x component, that is going to be mathf dot sine delta x divided by player scale dot x. So that's the x component. The y component is going to be 1 divided by player scale dot y, and our z scale is just going to be 1. 1. There we go. So all this code is counteracting all that code is counteracting the scaling of our moving platform. So let's try this out. I'm gonna play the game again, and I'm gonna move on to our moving platform if it gets close enough. So I'm walking on the moving platform. I am now a child object of the moving platform. I move around. I'm not obscenely stretched. I can move on the platform. The moment I jump off, I stop being a child object of the moving platform. Like anytime I jump, that's when I detach myself. That's when I detach myself from being a child object of the moving platform. I almost had it. Let's try it again. No. Back. Okay, maybe I'm a little too far now. So, but really the basics is there. That is how we keep the player from being stretched like that. Okay. So, one other thing worth adding in a platformer game is this. Suppose we had even more platforms. So we move this one here, and then we can move. Suppose the level keeps going after this, so. Suppose our level kept going like that for a while. So I have a few platforms already set up, and I may have screwed that up. Let's try again. Come on. I want to get on the moving platform. No. Well, maybe I have to move this cube closer here and wait for the thing to come back. Okay, now I move on the moving platform, and I would like to keep going this way. However, the camera, as you can tell, doesn't move with the player. Now, there are several ways to get the camera to move, and there is one very easy way, but it's contingent on being centered on the player exactly. So what I'm going to do, I'm going to set the player's position to be 0, 0, 0. However, I'm going to move the player to be a little bit lower, so the position is instead 0, negative 1.5, 0, and the camera will be attached to the player. So this is a quick and dirty way of getting the player to move. No, this is a quick and dirty way to getting the camera to move with the player. And yeah, this does work. It's just that it might be a little bit jarring to see the camera move exactly with the player. So if you want something a little bit smoother than that, then let's consider adding the following code. So we're gonna need to add one more script to our project, and that is going to be, I misspelled that. Try again. Alright, let's try that again because I misspelled that script. It was supposed to be follow cam. So I'm gonna open up this script. And all of this code I don't even need. So I'm just gonna delete all that, and I'm gonna add only just a few fields. Actually, I only need one field, and that is public transform target. And I'm gonna add a different method, and that is late update. So what late update is, it's like the update method, except it gets called after the update method. So late update is called after the update method. So I'm gonna say transform dot position equals new vector 3 for the x component. That's gonna be target.position.x, target.position.y, target.position.z. Hold on, let me double check this. Okay, so I had to double check that because for the x and y values of this vector 3 here, it's going to be the x and y position from the target.position. So target.position.x for the x component, target.position.y for the y component, and we're not going to use the target's z position, rather we're going to use the camera's z position. So that's the one thing that tripped me up. It was supposed to be target.position.x, target.position.y, and then transform.position.z. So in code, this is going to do the same thing as having the player have the camera attached to it. And as we've shown, we can attach the player. We can attach to the player the camera. We can have the player attached to the camera. But if you wanted to do this in code, then I'm gonna have to attach the follow cam script onto the camera, and then we have this empty field here for the target, and that is going to be the player. So I'm gonna drag and drop the player here into this field here. So now, basically, the camera is gonna follow the player no matter where the player goes. And yes, this does work, and it's about the same as having the player have the camera attached to it. I will say this right now, camera movement is like its own subject. It's like, well, not a subject in, say, a programming class, but it's its own topic of discussion. Like, say in a third-person game, for example, how do you want the camera to move if the player is up against a wall? However, as I said, maybe it's a little bit too jarring to have the player's movements directly translate to... It might be a little bit jarring to have the camera follow the player's movements exactly. And in many games, the camera does not exactly follow the player. Sometimes the camera will lag behind slowly behind the player, and when the player stops moving, the camera is gonna slow down and stop. So the player, if I can demonstrate this with a few objects I have on hand on my table. So let me just grab a few random things on my table. So what happens, what's going on is the player and the camera are moving exactly with one another. That might not always be the best thing we want to do. Instead, maybe what we want is have the player move and then the camera move, and then the camera catches up to the player. So if the player moves a little bit backwards, the camera is going to lag behind but still follow the player. So that is the last change we're going to do to any of our scripts, and then we can say that our base game here is complete. Complete is a relative term, but that is why we have our midterm project of expanding, say, either this game or the other two games we've been looking at. Okay, let's add those additions right now. So, I'm gonna need another public field, and that is gonna be a float. Public float smooth time equals 0.2f. And then I need a private field. Private vector 3 velocity equals vector 3 dot zero. So we have a velocity vector, but it's currently 0. What I'm going to do is I'm going to comment out all of this code. So we're going to replace that code entirely. I'm going to say vector 3 target position equals new vector 3, and actually I'm just going to comment, I'm going to copy part of this comment and just paste it down here. So it's going to be the same X, Y, and Z positions as we had before, but we're not going to use it just yet. Rather, we're going to do some smoothing on it so that the camera lags behind a little bit from the player. So if the player does any sudden movements, like goes back and forth really quickly, if the camera were moving exactly with the player, it's also going to capture those jarring movements with it. So with the smoothing, if the player suddenly moves back and forth, then with the camera lagging behind and slowly catching up to the player, those sudden movements are going to smooth out, and it's going to make for a rather less nauseating experience. Okay, so now I'm going to say transform.position equals vector 3 dot, and this is going to be a method that's this is a method that is part of the vector 3 class, and that is smooth damp. Now it's going to take in 4 things. Transform.position, that's the first thing. That's our current position. The next one is a target position. So that's going to be target position, which is, well, up here. We need ref velocity, which is going to be this. And we need that ref keyword as part of it, our call here. And finally, we need smooth time, which is going to be this value up here. So the cumulative effect of all of this is the camera is going to move, but its movements are going to be smoothened out compared to the player's movements. So let's try this out right now. I'm going to play the game here. Yeah, see how the player... It's a little hard to notice, but basically, any movements that I do, the camera's going to move, but there's going to be a delay. So the camera lags behind the player, but the camera will always catch up to the player once the player stops moving. In fact, maybe I can exaggerate this by changing the smooth time to a larger value, say 2. If I do that and I try to move around, maybe it's a little bit too slow, but it gets the point across. Any movements that we do, any jarring movements that we try to do, with the player, they're going to be smoothed out as the camera lags behind and catches up with the player. So let's set this back to 0.2 because that was a rather exaggerated version of what we were doing. So basically, we can move around the player's movements. Basically, if I try to move back and forth like this and try to go nowhere, it's not gonna violently shake the camera along. It's not gonna make the camera violently any like sudden and brash movements I do with the player is not gonna translate to sudden and brash movements on the camera. All that gets smoothed out, so we have this smooth experience where, as I said, the camera lags behind the player, but the camera always gets to catch up. So now we have a fully working, well, basic platformer game that we could, for example, expand upon and build upon as part of our midterm project. So regarding for sections 1 and 2 for spring 2024, your midterm project is going to be based on expanding either this or any one of the other games that we've been looking at. So your team will be working together to expand one of these games. I'll have instructions on Canvas on what am I looking for. Obviously you're going to be building up on one of these games, but when you do, don't just leave everything white boxed, but don't expect to have a fully polished game because, well, there's still a couple of topics we have to go through before we can do that. But basically, have a working demo game that is worth showing to the class that expands on any of the 3 basic games that we've been working on so far. I'll have further details about that on Canvas, but for anyone who's watching this in the future, what I just said might not apply. So if future me has ever assigned this video for future students to watch, then future me might have different instructions by then. But basically, for spring 2024 class, you're gonna be working on expanding one of 3 different games that we've been looking at so far. In fact, throughout the whole course, I've been hinting at, hey, let's work on. I've been giving you ideas on how to expand these games as well. So when I say, hey, we can change a few things in the scene controller for the first-person shooters, so instead of spawning one enemy, it spawns several enemies. Or in the memory game, I said we can probably change this so instead of locking ourselves to only 4 card types, we can have multiple card types. Or we can have the whole thing integrated as into a larger game where the memory game is merely a mini game. So yeah. So our midterm project is going to be, you as a group are going to be picking out one of these games, and if you haven't worked, and if you haven't, well, if you've been working on your project already, then there you go. If you've been waiting specifically to work on the platformer game, then here are your instructions. You might need to do some catch-up. So, for these two classes, I'm gonna see how everyone's doing and see if I need to make any adjustments regarding that. Okay, that's gonna be it for the video. And, well, now we have all the instructions for making a 3D platformer. If you have any questions, feel free to contact me, and I guess I'll see you in the next video. Thank you.